Hello and welcome back. We'll finish up section 8.4 in this video, and just as a reminder, from something quite a while ago, one common estimate for the standard deviation of a population is about a quarter of the range. When it's normally distributed, this is going to be approximately the right value. In a couple of the homework questions, they ask you to test whether or not this is a good estimate or not. This is called the range rule of thumb. Rule of thumb just meaning, yeah, it's approximately right in quite a few situations, but maybe not the perfect one, maybe not the perfect estimate. So let's look at an example where we're just testing a sample standard deviation. We're testing a claim with a sample. So we've got an inspector, and they're testing whether or not sprockets are being made consistently. So we want to have the standard deviation be reasonably small. So in a sample of 29 sprockets, their mean width is 1/2 inch, and the sample standard deviation is 0.0035 inches. But the boss claims that the standard deviation is going to be 0.003 inches. So this is the sample standard deviation is slightly bigger than what is expected. So the question is what is expected true? Can we say that the actual standard deviation is 0.003 and our sample was just a bad sample? So we should go through that same process as before. So we can write down our claim is that the standard deviation of width of sprockets is 0.003 inches. So then we need a symbolic claim. And this will be that the standard deviation is in fact equal to 0.003. Okay, so far so good. However, we can write down our null and alternative hypotheses. So the null hypothesis is always going to be roughly the symbolic claim, but we want to make sure that we have an equal sign in the middle. In this case, our claim is the same as our null hypothesis, whereas our alternative hypothesis is going to be essentially the opposite of this claim. We don't want an equal sign in the middle. We'll either want a less than or a greater than or not equal to. And in this case, we're not testing whether or not something is less than another value or greater than another value, just whether or not it's equal. So our alternative hypothesis should just be that the standard deviation is not equal to 0.003. We need our significance level. And in our question, we weren't given one explicitly, but maybe these sprockets are pretty important. Maybe they go into some medical devices. So let's choose a small significance level. Remember that the significance level refers to the probability that we get essentially a false positive when we reject the null hypothesis, but it was in fact true. So we want that probability to be quite small. We don't want to make any errors, so we want the probability of making an error to be small. Next, we have to find our test statistic. For this, we'll just use StatCrunch. And if we come to StatCrunch, in statistics, we can come down to variance statistics. Remember that StatCrunch doesn't like working directly with standard deviations. They work with the variance, which is just the standard deviation squared. We have one sample, and we don't have the individual data values. We don't have the width of each sprocket that was measured. We just know the summary of that information. So we will do this with summary. And it asks for a couple things. The first thing that it asks for is the sample variance. So we will need to come back and calculate this. So our sample standard deviation was 0.0035. So our sample our sample variance is just this squared. And if we plug this into a calculator, we will get 0.00001225. So pretty small number, but this is the variance. So we can type this number in. So 0.1234, 1225. Our sample size, there were 29 sprockets tested. And then we need to write our hypothesis test down. So the null hypothesis is saying that the variance, the standard deviation squared, is going to be equal to what? Well, up here, we have our null hypothesis is the standard deviation equal to this, but we don't want the standard deviation, or I should say StatCrunch doesn't want standard deviation, it wants it squared. So if we put this into a calculator and square it, we'll get 0.000009. So 5 zeros and a 9. So let's type that in. 0.12345 And our alternative hypothesis is just that the variance, standard deviation, is just not equal to this number. And that's everything. For optional graphs, I will plot the p-values just so that we can see exactly what's going on. And we can compute this. So here, we can see exactly everything that was going on. It tells us what the null hypothesis and the alternative hypothesis were in terms of the variance, so everything's being squared here. It tells us our sample variance, which we calculated, 0.0035 squared. Our degrees of freedom, one fewer than the number of elements in our sample. And our chi-squared statistic, so this is our test statistic, is 38.1 repeating. That's what it looks like. So our test statistic, our chi-squared, is going to be 38.1 repeating. Next, we'll need to know our p-value. And in this case, the p-value was calculated exactly for us. It is 0.1926. I imagine that this has had quite a few decimals after that. This has been rounded. And when we compare this to our significance level, this is much greater than our significance level, which will mean that if we are considering our null hypothesis, we fail to reject. So we cannot reject our null hypothesis. So there's not enough evidence to be able to reject this claim here. But this was our original claim as well, that the standard deviation for the width of the sprockets is 0.003. So let's write that down. So our conclusion, there is not enough evidence to reject the claim that the standard deviation of width of sprockets is 0.003 inches. And realistically, what this would mean is if we can't reject this claim, that supports the claim that 0.003 inches is the actual standard deviation. So in our sample of 29 sprockets, it seems very reasonable to expect that the standard deviation of all the sprockets is 0.003. If this if this was a very important, that they knew exactly what the standard deviation was, having a small significance level is good because that decreases the error, the probability of getting an error. But also, if those were very important, we could simply take a bigger sample size. With a bigger sample size, we have more confidence that the sample standard deviation is going to be closer to the actual population standard deviation. So maybe 29 isn't enough here. And this is where we'll end Chapter 8.